Everyone, today we are going to learn polar versus nonpolar. So two key terms that you need to know when we discuss molecular shapes and Lewis structures. So before we talk about polarity, let's talk about electronegativity. So remember, electronegativity is the ability of an atom to attract electrons. So that means if you have a high electronegativity like fluorine, then you're going to be able to pull more electrons towards you. So here, fluorine has a stronger pull on electrons compared to carbon. If you have a low electronegativity, that means you got a weaker pull on electrons. So what are the two types of covalent bonds? We have nonpolar, which means that electrons are shared equally. So what that means is these electrons are being pulled equally in both directions, right? Neither hydrogen is pulling these electrons any stronger than the other. And so therefore, the electrons are being shared equally. Nonpolar, equal sharing. In a polar covalent bond, the electrons are unequally shared. So what this means is, in this case, the electrons are actually slightly more pulled towards the chlorine compared to the hydrogen, right? As it says here, it's closer to the chlorine. But it's not completely taken from the hydrogen. It's still being shared. It's still a covalent bond. But again, this is an unequal sharing. So in a true nonpolar covalent bond, you might want to think of it like a tug of war, right? You got people pulling on both sides. If it's nonpolar, then it's completely equal pulling. And so why are electrons shared unequally? Well, as we just mentioned, it depends on differences in electronegativity. Right? If there's a really strong electronegativity and a large difference, the electrons just get ripped off and they're transferred, and that's ionic. And then if they're not completely ripped off, then they're going to be shared. And if the differences in electronegativity are really small, then they're shared equally. If they're kind of in the middle, then the electrons are shared unequally, which is polar. Okay. All right, so let's look at how we can determine polarity when we look at shapes. So first we want to draw the Lewis structure of this and then determine the shapes. So silicon has 1, 2, 3, 4 valence electrons. Each bromine is going to have 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and then we want to form our single bonds here. So we've got our structure. Now we want to name the shape. So 4 atoms bonded. Remember, the prefix for 4 is tetra, and so this is called a tetrahedral. Is it polar or nonpolar? So one way to check for polarity is to check for symmetry. So I'm going to check to see, is it symmetrical left to right? Yeah, there's a bromine on both sides. And then is it symmetrical going top to bottom? Yeah, there's a bromine on the top and a bromine on the bottom. So here, each bromine is pulling on all the electrons with equal strength, right? If they're pulling with equal strength and the electrons are being shared equally, then this is what we consider nonpolar. So in other words, nonpolar, we see that it is symmetrical. Okay, and that's why it's important to draw out these shapes. Let's look at another example here, example 2, PCl3. So phosphorus has 5 valence electrons. Each chlorine has 7. I'm going to draw my single bonds here. Cool, so we've got 3 bonded, so that's the structure, 3 bonded and 1 lone pair of electrons up here. So the shape here is going to be tri because there's 3 bonded, trigonal, pyramidal. Okay, is it polar or nonpolar? So again, we can use symmetry to check if it's polar or nonpolar. So if I just cut this in half, top to bottom, and I compare the left and right, you would think, oh, it is symmetrical. But when you cut this top to bottom, right, we see that on this side we've got electrons being pulled towards the chlorine, but there's not an equal pull going on the other side. Therefore, these electrons are being unequally shared, and this is a polar compound because this is not symmetrical, right? So we can see that it's not being pulled equally in all four directions, right? At the top, there's no chlorine up here to pull on this on these electrons, and because more of the pull is happening towards the bottom of our structure in a non-symmetrical way, it is an unequal sharing or a polar substance.